Assalamu alaikum, everyone. So let's get started with the third lecture of partial fractions. Now, in lecture number three of partial fractions, I'll be focusing on case four, the case four of partial fractions, and maybe a little bit more. So now we already know the basic idea of partial fractions. That is, a fraction will be given. We will look at the denominator. We will decide the case. If the denominator is linear, this is called denominator with linear factors. Naturally, the fraction has to be a proper algebraic fraction. What is the definition of proper? The highest power of numerator should be lesser than highest power of denominator, and that is the case. The strategy: denominator decides the case, write out the fractions, solve for unknown constants, write the final answer as partial fractions. This was the first question that we did. The second question, there were three linear factors, so there were three fractions. We would take LCM, we would equate the numerators, we would solve for the unknown constants in a particular manner. This was case number one. Then we started case number two, quadratic factor, a factor which is not factorizable. If it's factorizable, something like this, 4 minus x square, it would break it up into linear factors. 4 plus x square cannot be factorized. How would we write it? Linear factor at the bottom, constant at the top. Quadratic factor at the bottom, a linear expression in brackets at the top, so that when we take the LCM, we make no mistakes. Rest of the story is simple. Choose a value so that this bracket becomes 0. These two disappear. Find the value of A. Substitute the value of A. Choose x is equals to 0. Find C. Substitute A. Substitute C. Choose any value. Find the value of B. And yes, I'll be giving some homework also today for you to try it out. And then you can send me a PDF for that. And then I'll have it checked. So now that's how this thing is broken. Yes, or as always, I'll always give you the caution thing, which is it is a possibility that both B and C will have some values. It is a possibility that B will have some value, C will come out to be 0, or vice versa. It's simply not possible that both of them can be 0. And then we did questions related to binomial expansion. That will always be the case. We went over this last time. And then lecture number 2, that was partial fractions again. This is a linear factor. The power is 1 outside, the power of x is 1. If it's linear on the inside and the power is 2, that is a linear repeated factor. And the power is 1 on the outside, but the x has a power of 2, that's a quadratic factor. And we are limited to these three technically. So now denominator with linear repeated, once the linear is written as it is, once the linear is written with the square. Linear repeated case, all numerators are constant. Why not expand? Because the order is to factorize the denominator. We are ordered to follow this rule. So now A over the first factor, B over the linear factor with a power of 1, C over the linear factor with a power of 2. Be very, very careful. Watch the last time video, how I was taking the LCM. Find the three unknown constants, write things as it is. And then I think we did another question. And I think we also did the binomial part of it. There were three fractions, expand each one individually. Yes, neatness, simplification, that's the name of the game. Expand each one separately, add it all up, and then you get the answer. So that was end of lecture number 2. And now we are starting with lecture number 3. And let me just have a look. Where am I starting this? I'm starting from here. So now in this particular lecture, which is partial fraction lecture 3, let me just highlight this. So this is partial fraction lecture number 3. We are still on algebra. So this is lecture 3. of partial fractions plus a little bit of polynomials and a little bit of long division. So they both are in will be in the same package. And it's about P3, it's about algebra, and so on. And then we would also evaluate how much have we done, how much is left, what kind of questions can we attempt, what is the weightage of this. So all these things will inshallah be dealt at the right time. So now let's talk about proper fraction versus improper fraction from the perspective of arithmetic, from the perspective of numbers. So this is from the perspective of numbers, from the perspective of arithmetic. If I have something like 2 over 3, 4 over 7, 5 over 9, 7 over 13, these are proper fractions. If I flip each one of them, 2 over 3 becomes 3 over 2, 4 over 7 becomes 7 over 4, 5 over 9 means 9 over 5, 7 over 13 means 13 over 7. So these are examples of improper fraction. What is a proper fraction? The numerator is smaller than denominator. Numerator is smaller than denominator. That is a proper fraction, as simple as this. What is an improper fraction? Improper fraction, that is numerator, is greater than denominator. Okay. Now the question is, let me take an improper fraction. And this improper fraction, can I write it as a mixed number? Can I write this thing as quotient plus remainder over divisor? Of course, I can. So now let me apply this knowledge. So now people, let's look at the working for this. Let me take a fraction, something like 7 over 4. Put 7 on the inside, 4 on the outside. 4 ones are 4, negative sign, remainder is 3. So this 7, this is the dividend. This 4 is the divisor. Divisor, dividend. This 1 is the quotient. This 3 is the remainder. So technically, 7 over 4 can now be written as 1 whole 3 over 4. That is quotient, remainder, divisor. All good? Quotient plus remainder over divisor. You can also write it like this. 1 3/4 is 1 plus 3/4. That is quotient plus remainder over divisor. Now let's apply this knowledge in algebra. Now let's say I want to practice something new, and then I'll go back to partial fractions. That is the concept of algebraic division. And then I'll apply it to partial fractions. Let's say I have x squared plus 4x plus 5, and I want to divide it with x squared plus x plus 1. So now the decision is taken by the highest power of the numerator. This is highest power of numerator, and this one is highest power of denominator. And we are just practicing algebraic division. So now this x squared divided by this x squared, what do I get? I get a 1. So this 1 becomes the quotient, and I write it over here. I take this one, I multiply it with every single term of the divisor, and I write it over here. x square plus x plus 1. Next thing, I'll change the sign and add. That is a beautiful name for subtraction. Change the sign and add. That is a beautiful name for subtraction. So therefore, negative, negative, negative. So x square would cancel out. 4x minus x is 3x, 5 minus 1 is 4. This is the divisor. So now this is the quotient. So in other words, x square plus 4x plus 5 divided by x square plus x plus 1, that is an improper algebraic fraction. Why is it improper? Because the highest power of numerator, the highest power of numerator, and this is highest power of denominator, they are equal. This is, and this is, it's equal powers. So if it's equal powers, that is an improper algebraic fraction. There it is, improper algebraic fraction. How can I write it properly? I can write it as a quotient. Quotient is 1. Divisor is 3x plus 4. So 1 plus 3x plus 4 divided by the divisor, which is x squared plus x plus 1. X squared plus x plus 1. Now, so far, so good. Let me share these images with you. These three images, actually these two images. I want you to first copy it down and then we will continue. So now people, let's resume. So what we have done is that we have learned the basics of algebraic division. Highest powered divide, that gives the quotient. Quotient multiplying with every term inside in the divisor. Write it out. Change the sign and add. That's another way of subtraction. What you get is the remainder. Let me just correct myself over here. This is the remainder. So this is over here. And what we do is that the quotient, remainder, divisor, this is quotient, this is remainder, this is divisor. So quotient plus remainder over divisor, that is how we write it. Okay, all good, all clear. By mistake, I wrote divisor over here. So now let's look at this. How can I apply this to partial fractions? Now, when we talk about partial fractions, so this is case number 4. So this is case number 4 of partial fractions. That is improper algebraic fractions. So when it's improper algebraic fractions, there are two possibilities. First of all, let me use the term degree of polynomial. An algebraic expression with many terms as a polynomial. I can also call it the highest power. So now the highest power of the numerator, if it equals to highest power, let me write this thing as HP, of denominator, that is improper. Highest power of numerator is greater than highest power of denominator, that is also improper. So they both are improper algebraic fractions. Improper algebraic fractions. Why is this the case? The highest power of the numerator is 2. The highest power of the numerator after multiplication is 2. So it falls into this category. And this is part of the P39709 syllabus. P39709 syllabus. Yes, this is also improper, but this is out of syllabus. So all our questions will be based on such things in which the highest power of numerator equals to highest power of denominator. So we have 4x squared minus 13x plus 13. So let me just copy this thing. And let me go to the next page. Let me paste it over here and let's work it out. So step one of case 4 is multiply out the denominator. So the divisor is actually 2x minus 1, x minus 3, multiply it out for the purpose of long division. So 2x into x, that is 2x squared, 2x into negative 3, negative 6x, negative x plus 3, that is 2x squared, negative 7x plus 3. This is the divisor, these two, or this thing, they both are the divisor. This is the factorized form of the divisor. This is the expanded form of the divisor. Technically, they both are the divisor. That's the step number one. Step number two, that is long division. That's the slang that we use. The proper name is algebraic division. So now let me write 4x squared minus 13x plus 13. 4x squared. 4x squared minus 13x plus 13. And yes, I should have checked it first, but of course I know that it is a question belonging to this category. So now over here, this is the highest power of the numerator. And over here, this power 1, this power 1, that will make it power 2 over here. That will make it power 2 over here. So this is highest power. Let me just, this is highest power of numerator is 2. This is highest power of denominator is 2. All good? So therefore, this is an improper algebraic fraction. So that makes it case number 4 initially. Now, if I do the long division, that is what I'm supposed to do. Change the color. Let me write this thing over here, 2x squared minus 7x plus 3. 2x squared minus 7x plus 3. Take the highest power. Take the highest power and divide. So 4x squared over 2x squared is 2. Multiply with every single term of the divisor. So 2 into 2 is 4x squared. 2 into negative 7x is negative 14x. 2 into 3 is 6. Draw a line. Change the sign and add. Naturally, the x squared term cancels out. Negative 13 plus 14. 14 minus 13, that is 1, which is x. And this is 13 minus 6, which is plus 7. The quotient is 2. The divisor is this thing which we already know as the factorized form 2x minus 1, x minus 3. 2x minus 1, x minus 3. The remainder, which is x plus 7. So therefore, I should write this thing as quotient plus remainder over divisor. Quotient is 2. Remainder is x plus 7. Divisor is 2x minus 1 into x minus 3. Now, within case 4, this is another case. Which one is this? This one is denominator with linear factors. You can only apply partial fraction. Partial fraction can only be obtained from proper fractions. So unless and until you have a proper fraction, you cannot continue. This quotient, leave it on the sidelines, but don't forget it. Don't forget about it till the very end. Now, what we will do is that, let me add a page. That is x plus 7. So this is x plus 7 divided by 2x minus 1 into x minus 3. This is identical to a over 2x minus 1. This is b over x minus 3. Take the LCM. And this you have already done. So therefore, this is a into x minus 3, b into 2x minus 1. Now it becomes so handy that officially I should have written the denominator first, but it becomes second nature to us. Now x plus 7, this is a times x minus 3, b times 2x minus 1. Let me just copy this thing out. Let me paste it over here. Let me plug in a value. Let x is equals to 3. If I plug in 3, a will disappear. So 3 plus 7, this is a times 0. This is b into 2 into 3 minus 1. 6 minus 1 is 5. This is 10. This is 5b. Therefore, b comes out to be 2. Write b over here as 2. Now, there were two options. Either I could have substituted x is equals to half and cancelled out b and evaluated a, or I can choose any other value. Let me put any other value, which is let x is equals to 0 because the value of b is already substituted. So therefore 0 plus 7, this is a, 0 minus 3, this is 2, 0 minus 1. And yes, one thing, after the substitution, this becomes equal sign. So after substitution, there should be equal sign. Before substitution, it was identical. After substitution, it's equal sign. So now over here, let's work it out. So 7, this is minus 3a, that is minus 2. Take 2 to the other side, and let me just double check one thing. So if I'm plugging in 0, 0 plus 7, 0 minus 3 is minus 3a. This is 2 into 0 minus 1, that is negative 2. Take it to the other side. 9 is equals to minus 3a. Therefore, a comes out to be negative 3. Now, a is the numerator. Let me copy this down. So hold for a second. This thing, the final answer. So now the final answer is this thing. A is negative 3. So a is negative 3. B is 2. B is 2. That is the partial fraction. And don't forget this 2 at the very front, the quotient 2. So therefore, this is 2 over here. And that is the final answer for partial fractions. Let's double check. So this A, look over here, they have written this thing as A. So A is 2. B is negative 3. Negative 3 is the numerator of 2x minus 1. Negative 3 is the numerator of 2x minus 1. C over x minus 3, C is 2. So this is 2 over x minus 3. It doesn't make a difference if I call it A and B. If I call this as A, this is B, this is C. If I call this thing as QRS, it doesn't make a difference because we have to write it as partial fractions, and that's how it's done and dusted. So let me share these images with you so that you can copy it down thoroughly. And then I will give you a question to try. Let me show you which question I'll be giving you. This one. So basically, we should be focusing on the very first part over here. That is this thing. So just focus on this thing, fx and partial fractions, and do everything just the way I have done. So now, people, let's look at the question that you people were supposed to try it out. And some of you have sent over there working to me. I think it looks good. So first of all, highest power of numerator is 2. Highest power of the denominator is also 2. So the very first thing that I should write is that it's an improper algebraic fraction. So that makes it case number 4. And now it's about long division, algebraic division. And then later on, if I look at the denominator, that will make it case number 1, denominator with linear factors. So case 4 could have case 1, case 2, case 3 in it. Very first step, multiply out the divisor. So this is a linear divisor. This is a linear divisor. If we multiply it out, we get a quadratic divisor for simplification purposes, for long division purposes. So that is step number one. What is step number two? That is algebraic division. We try out the algebraic division the way that I've just taught you. We get a quotient of 4. We get a divisor of 8x plus 7. This is not divisor, my bad. Last time I also wrote divisor over here. This is actually the remainder. And this is the divisor over here. This is the factorized form of the divisor. So this is quotient plus remainder over divisor. This is quotient plus remainder over divisor. Now this is case number 1. So if it's case number 1, then we work it out. So technically this is step number 3. Step number 3 is the partial fraction thing. So this is a constant over the first factor, another constant over the second factor. We do the working, and these are the fractions that we get. Don't forget to write the quotient back. 4 plus 3 over x minus 1, negative 1 over 3x plus 2. Of course, you can also write it 4 plus 3 over x minus 1 minus 1 over 3x plus 2. That is the final answer. They have written like a plus b over x minus 1. And this is c over 3x plus 2. A is 4, perfect. B is 3, perfect. C is minus 1, perfect. The name that they use, PQRS, ABC, KLM, it doesn't make a difference. So that's how we complete partial fraction. So partial fraction, all 4 cases, 1, 2, 3, and 4, it's all done and dusted. So in the next class, we'll be starting with polynomials. Take care, everyone.